Now we go on to adding and subtracting dissimilar rational algebraic expressions. But what do you mean by dissimilar rational algebraic expressions? So when you see dissimilar, meaning these rational algebraic expressions have different denominators. Okay, let's review first on adding and subtracting dissimilar fractions. Okay, example. Three-fifths added by 2/3 minus 1/2. Okay. So, as you can see, they have different denominators. So, class, you cannot add directly the numerators if they have dissimilar denominators. So, what will you do? You change this into similar fractions or similar rational algebraic expressions. So, how? So, we're going to use the concept of LCM, least common multiple. So, since we're talking about denominator now, so we'll name that as LCD. LCD, least common denominator. So, you have your 5, 3, 2 denominators. So, we're going to look for their LCD. So, 5, 3, and 2, their LCD. So, 5, 3, that would be 15. Then I have your 2. So, you have their LCD 30. Okay. Okay, since the denominators are changed, of course, you come up with new numerator. So, how? So, 30 divided by 5, that is 6. And then you multiply it to the existing numerator 3. Next, 30 divided by 3 to the denominator 3, that is 10 times 2. And then, 30 divided by 2, that is 15 times 1. So, you have 6 times 3, that is 18. 10 times 2, that is 20 over 30. 15 times 1, 15 over 30. So, as you observe, they have the same denominator already. So, now you can add or subtract directly the numerators. 30. So, 18 plus 20 minus 15. That would be 18 plus 20, that is 38 minus 15, that is 23. Okay? If the fraction or the rational algebraic expressions is still factorable or can be simplified, so you simplify that into the lowest term. So since this cannot be simplified, so this would be the final answer. So again, if you encounter adding or subtracting dissimilar rational algebraic expressions, first you change into similar RAE. How? So you get their LCD first, and then you get also their new numerators. Okay, let's have example on adding and subtracting dissimilar rational algebraic expressions. Add or subtract. We have here 5 over 18 a to the power of 4 b plus 2 over 27 a cubed b squared c. Okay. So, as you can see here, these RAEs are dissimilar since they have different denominator. So what will you do here? Of course, you get their LCD. So first, get the LCD of 18 and 27. How? Okay, I'll drag this. Okay, 18, so it's easy for you to use prime factorization. 18, that would be 3 times 3 times 2, kasi 9 times 2. 27 is 3 times 3 times 3. So, get the LCM. So, 3, they're common, another common. And since we're talking about LCD, so, you include also the non-common. So, you multiply. So, of course, 3 times 3, 9 times 2, 18 times 3, that is 54. So, that's first the LCD. So, you have 54. Next, a to the power of 4a cubed. So, for the LCD, you pick the variable who has the most or the highest exponent, which is a to the power of 4. Next, b, and then b squared. So, of course, LCD for that is b squared. Okay, for the first denominator, 8 and 8 to the power of 4 divided by b, there is no c. But in the second denominator, there is c. So, meaning c also included in the LCD. Okay. Now, afterwards, so again, divide the LCD to the existing denominator. So, 54 divided by 18, that is 3. Then, a to the power of 4 divided by a to the power is 1. So, times 3, that's still 3. B squared divided by b, that is b. And then, yung c, there's no c there. So, c divided by 1. So, that's c. Then, times 5. And then, 54 divided by 27, that is 2. Then, a to the power of 4 divided by a cubed, that is a. B squared divided by b squared is 1. C divided by c, that's 1. Then, times 2. I did not include 1 because 1 cannot affect the product. Okay, as you can see, they have the same denominator now, but still you need to simplify the numerator. 3bc times 5, that is 15bc, plus 2a times 2, that is 4a. All over 54, a to the power of 4, b squared, c. So, class, at this point, when you look at the numerator, there is no GCMF. And they are unlike terms, you cannot add them. So, meaning that that would be the final answer. 15bc plus 4a all over 54, a to the power of 4, b squared, c. Now, let's have another example. Two x over x squared plus 4x plus 3 plus 3x plus 6 over x squared plus 5x plus 6. Okay, as you can see, class, of course, they are dissimilar rational algebraic expressions since they have different denominators. So, in dealing with this, you have trinomials, which are the denominator. So, in order for you to get the LCD easier manner, so you first factor each. Okay? So, you have 2x, it's just 2x. Okay, and then you have denominator x squared plus 4x plus 3. So, you factor that out, expecting that you have two binary factors. So, factors of x squared, 2x, And then 3, that would be 3 and 1. Then you can get that the middle term for x. And then you have there, you could also factor the numerator. Okay, the numerator, they're common. The CMF is 3. Then let's divide directly. 3x divided by 3, that is x. 6 divided by 3, that is 2. Okay. And then for the denominator, you factor that out. Okay, so you have factor of x squared, 2x, and then 6. And your goal is to get 5x, so that would be 3 and 2. Class, why is it I factor the numerator? Because sometimes, just like this, you can simplify the given RA. Where here, you have your common binomial factor, which is x plus 2. You can cancel that out. So this becomes 2x, copy still, x plus 3, and then times the binomial of x plus 1. So you have 3 over x plus 3. So simplifications is very important so that later you will not complicate yourselves while finding the sum and difference. So now we could have the LCD. Let's find the LCD. So first, in finding the LCD, you look for their common, which is x plus 3. Okay, drop it. And then next, you get their non-common factor. Then, yes, that would be x plus 1. Here, x plus 1. So that is the LCD. And then afterwards, you divide the LCD to the existing denominator. So x plus 3 times the quantity of x plus 1 divided by this. That is 1. And then times 2x. The existing numerator. The same thing, LCD divided by this denominator x plus 3. So meaning the common is x plus 3. So cancelled out the x plus 3. So the remaining is x plus 1. And then multiplied by 3. Okay, and then next, okay. We can now multiply. 1 times 2x is 2x. Okay, we could add directly. Plus x times 3, that is 3x. Plus 1 times 3, that is 3. So you have here 2x plus 3x, that is 5x. So there are 2 plus 5x, then plus 3 over the binomial of x plus 3 times the binomial of x plus 1. So as you can see, there is no common monomial factor. So meaning the final answer is 5x plus 3 all over x plus 3 times the quantity of x plus 1. Now let's go on to the third example. Okay, for this example number 2, you have your addition. How about if we change that into subtraction? Okay, let's have that. Okay, in number 1, we have already get their LCD. So, we'll directly do this. So you have there x plus 3. I mean, refer to example number 2. Minus. There. I will just pick up the simplest form. 3x plus 3. Please refer to example number 2. And then 2x. Okay, the LCD again is x plus 3 and x plus 1. Same here. So divide the LCD to the existing denominator, that is 1 times 2x. Here, LCD divided by x plus 3, that is just x plus 1 times 3. And then multiply 1 times 2x is 2x over x plus 3 times x plus 1. Here, x times 3, that is 3x. 1 times 3, that is 3. Over the quantity of x plus 3 multiplied by the quantity of x plus 1. Now let's subtract. Okay, you have there 2x minus 3x, that is negative x. 2x minus, no. Since there is no similar term of 3, so just minus 3, that is, okay, minus 3. So you have x plus 3 times the quantity of x plus 1. And then, okay, the numerator still can be factor, which is its common factor, or GCMF, is negative 1. Negative x divided by negative 1 is x. Negative 3 divided by negative 1, that is positive 3. Over x plus 3 times the quantity of x plus 1. So meaning, there is common binomial factor, which is x plus 3. So you cancel that out. So meaning, the final answer would be negative 1 over x plus 1. Let's proceed to example number 3. So you have there 3 over x plus 2 plus x over x squared minus 4. Minus 4 over x squared plus 3x plus 2. So you have 3 RAAs here. So of course they are dissimilar since they have different denominators. So just what I told you, you need to get their LCD first to get similar rational algebraic expressions. So you factor that first in order it's easy for you to get the LCD. Okay, x plus 2 is the factorable, so you just copy. X squared minus 4 is the difference of 2 squares. Expected, you have 2 binomial factors. The factors are x plus 2 and x minus 2. Minus 4 over, you have your x squared plus 3x plus 2. Still, you have binomial factors, 2 binomial factors. So x squared factors x, and then 2, you have there positive 2 and positive 1, since the middle term is 3x. Now you get the LCD. So x plus 2 is their common, so copy. And then x minus 2 is not common, so just copy. And x plus 1 is another not common. So for LCD class, you just multiply copy the common factors, and then you copy also the non-common. Since you get the LCD now, of course, you will have also new numerators. So you have your LCD divided by the existing denominator, which is x plus 2, meaning x plus 2 is cancelled out. So the remaining is x minus 2 times the quantity of x plus 1 times 3. And then this, you divide. So x plus 2 is cancelled out. And then x minus 2 also, meaning the remaining is x plus 1. And then you divide it with x. Then multiply with x. Here also, the LCD common is x plus 2. You can cancel that out. And then also x plus 1. Meaning the remaining is x minus 2. Multiplied it by 4. Okay, you simplify. So, x plus 2 times x minus 2 times quantity of x plus 1. So, this class, x minus 2 times x plus 1, that would be x squared minus x minus 2. You can check in your notebook, class. Times 3. And then, plus x times x, that's x squared. 1 times x, that's x. So, over x plus 2 times x minus 2 times the quantity of x plus 1. Minus x times 4, that is 4x. Negative 2 times 4, that's negative 8. Times, over x plus 2 times the quantity of x minus 2 times the quantity of x plus 1. Okay, let's continue. Okay, let's add. You simplify first the first. So you have your x squared times 3, that is 3x squared. Negative x times 3, that is negative 3x. Negative 2 times 3 is negative 6. Okay, so you have x plus 2 times the quantity of x minus 2 times the quantity of x plus 1. Okay, by the way, since these are simplified, you can now subtract them. X squared, there's no similar terms on the numerator. So just copy. But x here, similar term is 4x. So x minus 4x, that is negative 3x. And then minus negative 8, that would be positive 8. Over x plus 2 times the quantity of x minus 2 times the quantity of x plus 1. Now, we can now add them, the numerator. So you have our 3x squared plus x squared, that is 4x squared. Negative 3x plus negative 3x is negative 6x. Negative 6 plus 8, that is positive 2. All over the quantity of x plus 2 times the quantity of x minus 2 times the quantity of x plus 1. Actually, the numerator is factorable, but still, if you factor that out, there is no common among numerator and denominator. So, this would be the final answer. Okay? That is all about adding and subtracting dissimilar rational algebra expressions. Always remember, you change first the dissimilar RAS into similar RAS so that you could add and subtract the numerator. Okay, that's it. God bless you.